All right, so let's get going on today's class. So what we're going to be doing today is a sort of applied version of operational conditioning. We're going to take a look at some previously encountered topics. We're going to take a look at some new topics, and we're going to apply them to a specific example to illustrate them, which is gambling behavior and gambling addiction. But before we get to that, on to step 4 of the social media assignment. And what we're going to be doing for step 4, and this is going to be for the next few steps, we're going to continue that idea of giving before taking for your network. So far this has been really well done. So this is an example of one of the retweets that has been done. And again, at this stage in your academic career, at this stage in your psychology career, you might not have a lot of original content that you can provide. You're not, necessarily doing research. You don't necessarily have best practices in terms of how to teach psychology. You might not have a lot of material that you yourself can provide that's original, but you can definitely start helping out your network, start helping out your community by promoting their ideas, by amplifying their statements. So that's a great way, again, to become part of this and to start building your network, and also to start building your professional profile so that employers and grad schools later on see that you have an active social media profile. And yes, all of the things that you talk about in your professional profile are psychology related, indicating that clear interest to help convince them to hire or accept you. So that's what we're going to keep doing now for the next little while. So because this is going to be an extended period of time, because we got fall break, we're going to be doing 4 retweets from any of the psychologists that you currently follow. If you want to follow new ones, feel free to do that as well. So it'll be 4 this time, and once again, no comments are required other than the assignment hashtag. But if you do want to comment, if you're starting to feel comfortable enough to contribute that, then definitely read the do's and don'ts of networking online. It's a PDF that is available in Canvas. Mm-hmm.
Would that have information about who you should follow and who you shouldn't follow and follow back and all of that stuff?
The do's and don'ts of networking?
Yeah, or is that just more how you should conduct?
That's more about how I think you should interact.
Okay.
But the rule on sort of who to follow back, and in terms of what to post is an excellent question. What you want to do is you want to make sure that your account has a consistent message. So if you're following people for this one, we're building a professional psychology account, you would want to follow other psychologists, and they can be psychologists at any stage of their development in their career. So it could be top tier, psychologists that are doing TED Talks. It could be grad students at pursuing their PhD. It could be other undergrads, but you want to make sure that you're following people that are in that sort of psychology area. And then in terms of posting things, you want to make sure that you post things that are psychology related. So in terms of following people back, as you kind of build your network, you'll notice that some people will post a lot of useful information, and that will go into your feed. Other people will post not so useful information. Then if you follow them, that will go into your feed as well. So that's one of the reasons why when you follow somebody, maybe take a look at what they've been posting about. And if they're posting a lot of interesting psychology stuff, absolutely follow them for your professional feed. If they're posting a lot of things about their cat, maybe on your personal Twitter if that's what you're interested in, but you don't really want to clutter up your own feed. And that's also the reason why you want to make sure that your profile has a consistent theme. So on your profile, make sure that you're only really posting about psychology things. It can be anything, like psychology is a wide field, so it can be anything that's of interest to psychologists, but try to keep that consistent. So for example, one of the people that I followed, he was specializing in social marketing. That was his area. But he also loved sailing. He was a boat enthusiast, and he would post boat information as well. So when I followed him, I got this mix. of interesting psychology stuff that I could use, and the latest version of the 2019 model of this particular boat and all its features. And what happened was that at one point he sent out an announcement that he was starting a separate Twitter account for his boating interests. And I think what was happening is that he realized that his message was getting diluted, and he was cluttering up people's inbox and their feeds because they weren't following him for the boating, they were following him for the social marketing. So that's not what you want. You don't want to burden people with, oh, here's all this other stuff other than what you're following. So if you find that a professor is doing that, like say you followed somebody and all of a sudden you know more about their cat than about their research, definitely you can unfollow them and look for people more in line with that particular interest. But every decision that you make for your social media profile is all about benefiting you the most in psychology. So you want it to be about psychology, you want your post to be about psychology. And again, psychology is so broad that almost anything will touch psychology at some point, but you do want to make sure that it's that theme for your account. So, and then this thing does have information more on retweeting controversial information and controversial stuff. There's more, isn't there? The next little amount. But I mean, in terms of controversy and things like that, just be aware. I mean, there are certain things that you definitely don't want to get involved with. Definitely don't want to address. When you're retweeting, I would recommend at this point kind of keep it not like I said, not controversial. So one of the psychologists that comes to my mind is Jordan Peterson. And Jordan Peterson is split, there's people that absolutely adore him, love him, and send him hundreds of thousands of dollars on, it used to be Patreon, but he started up his own thing, and there's people that absolutely despise him. And if you follow him, and if you retweet his, some of his tweets, when you go and apply to a grad school, when you go to apply to, a job, you're kind of taking that 50-50 shot, right? That, are they going to be a supporter? Are they going to be something that's not a supporter? Whereas if you choose less controversial figures, then it's much more beneficial to you in that regard. So I would say if you're wondering, should I follow this individual, should I not follow this individual? At this stage, as you're kind of building your network and contributing to community, maybe err on the side of not follow, for the period of time. All right, so again, you want to retweet for the tweets from any psychologist that you follow, and make sure again that it's about psychology information. So they're posting their latest research, they're posting a link to a talk that they gave, they're posting advice on what to do, in a classroom. All of that is fine. And this time we're going to use the hashtag NextGenPsych 2019 for these particular four. So the last time it was FuturePsych 2019. This time we're going NextGenPsych, just so that we can keep track of those different stages. So that's part one of the social media development for this week. Part two is actually part of my big ask. So hopefully I've helped build this community enough that the big ask will be appropriate at this time. But my big ask for this is I have a student, where is he? That guy right there. So that's Christopher Crawford, and he graduated. He is currently a research assistant at IU Medical School, and we're doing a research project together, and we will be sending out very soon, hopefully either today or tomorrow, we'll be sending out a recruitment tweet for participants in this experiment. So it's being cleared by the IRB, so we're all ready to go. We're just waiting for the final word. And what I would like you to do, if you would help us out, is to retweet this to just help us out with subject recruitment. So just so that we are absolutely clear, I am not asking you at all to participate in this experiment. So it is unethical actually for me to ask you to do this experiment because you're currently my students, and that's kind of like a coercive thing. I don't want you to, you're not allowed to participate in research if you feel that it's coercive. So, just to be clear, this is not asking you to click on that link and do the survey. That's not what I'm asking at all. But what I am asking, and what is ethically allowed, is to just retweet this to help get the word out, to help spread the subject recruitment. So if you could do that, and this is also a nice way, once again, to get involved with the research community. So people that might follow you, employers later on, might see this tweet and say, oh, well, this person says that they're interested in psychology research, and look, here they were helping out a fellow psychology researcher. So for that one, if you are so inclined to help us out, 2 hashtags on that. Research opportunity, IUSB, that's going to help us keep track of the, this particular involvement. And then hashtag comics on Twitter, that's a hashtag for people that are interested in issues like scientific research on comics on Twitter. That's a hashtag that they use. So that'll be a nice way for them to identify this as well. So if you can use those 2. And this is going to be due not this Monday, but next Monday. So we have an elongated period of time for this because of the fall break. And Monday, October 28th, if you can help out with those 2 stages for our social media development stage 4. Any questions on that? All right, so now the open review session is officially open. So once again, we will open it up to any questions that people that you might have in order to get you prepared for the upcoming exam. But before we get to that, just in brief what you can expect on this exam, because we did cover a lot of different things. So there will be one basic probability question, working with a frequency distribution table, calculating out different probabilities. There will be one question on understanding the normal distribution curves and being able to recognize, for example, different areas of the curve. There will be a question on starting with a raw score and using the normal distribution table to figure out a percentage, starting with a percentage, using the normal distribution table to figure out a raw score. And then the rest will be hypothesis testing, where you will be asked to do 2-tailed tests, you'll be asked to do 1-tailed tests, and in the exam, unlike your homework, you will specifically be told 1-tailed or 2-tailed. So be aware of that. It will literally be the last sentence. Use a 1-tailed test with an alpha of this, use a 2-tailed test with an alpha of this, so watch out for that. And then on the 1-tailed test, it'll also indicate the direction, so be sure that you look for language such as, did it increase, did it get bigger, was it greater than before, or did the scores decrease, did they go down, was it less than before. So that's what's going to be on the exam. You do have a practice problem, so that brings it up to 3 kind of practice problems that I've given to you. 2 from last class, and then the one that I uploaded today, that 1-tailed test. That is literally what half your exam is going to look like. So the hypothesis testing portions will look exactly like that, just different questions and different hypothesis tests. But the last thing I want to do is just to make sure that everybody understands what it is that we're doing here and what it is that hypothesis testing is all about. So when you have your comparison distribution, right? So when you have your comparison distribution, that is your distribution of all these sample means, right? It's a distribution of all these sample means that could have been collected from your population, right? You have one of these sample means, because these are all the possible sample means that could have been collected from the population. This is why we use the comparison distribution, because we're using means rather than individuals. So your comparison distribution will have some mean, right? Let's say it has a mean of 40 and a standard deviation of 5. And that is nowhere in your textbook, there's nowhere in the appendices. So that's what we transform into that unit normal distribution. So we literally just take these scores and transform them, and transform every single mean into a unit normal distribution table like we were doing in chapter 2 that has a mean of 0 and a standard deviation of 1. And then what we do is we find our cutoff scores. Now the cutoff scores, they are that line in the sand at which point you yell shenanigans or call shenanigans on your sample. So what I mean by that is that regardless of where your line in the sand is, there are going to be samples that came from the original population that are in that area, right? So these tail areas, they exist in the distribution, right? These tail areas, they're part of the distribution. They're possible samples that you could have gotten from this untreated population. So what our tails really are these are the samples that are so unlikely that we are not willing to say that they still could have come from the known population. They're so unlikely to occur that we say they must have been from the treated population, right? So there's two possibilities for any of these samples. Either the sample comes from your original known distribution, or the sample comes from and belongs to your treated population. So again, what we do is we draw that line in the sand, and let's say that the line is with an alpha of 0.05. So we have a two-tailed test where we have 2.5% in one side, and we got 2.5% in the other side. And when we calculate our sample's z-score, let's say that our actual sample, right, so we collected data, and this, I don't want to put it there. This was the sample mean that we found. We collected our data, and this was the sample that we got, and there's the sample mean. So that's the sample that we have in our experiment. That's the treated sample. Now, this treated sample has a sample mean that could have been created by people in the untreated population. It would have to be created by extreme individuals from that untreated population. And you know that because it's part of this distribution of sample means that came from the untreated population. So the question is, how likely is a sample this large to have come from this untreated population? And that's why we do this, to find out that that sample mean is in this area. So if it goes into the tails, then we know there's two possibilities. It either belongs to the untreated, or it belongs to the treated population. Right? That's the only two possibilities. Either the sample that you treated has changed and now belongs to the treated population, or it was always part of the known population and your treatment did nothing, so it belongs to the untreated population. If your sample creeps into this tail area, that means that there is a 5% chance in this, for this alpha level here, for these tails, there's a 5% chance that your treatment did nothing. That means that there's a 95% chance that your treatment did something. And that's when we decide, yes, we're going to say that our treatment did something. So that's why crossing into this tail means that your treatment had an effect, your treatment did change the sample, because it's either that your treatment did something, or you're dealing with a very, very, very unlikely sample. And once we choose this line, once it crosses that line, we say it's unlikely enough to still belong to the untreated population. We're going to say it must have been the treatment that has caused these extreme scores. So that's why crossing that line is the crucial thing that determines whether it's part of the new treated population or still part of the untreated population. All right, so that is all that I wanted to make sure that we covered for on my end of this review session. At this point, let me know anything that you want to see. Again, if you want me to go over something in particular, if you want to use this time to try out that Excel sheet that was put together to give you a good idea if you have the complete set required to do the hypothesis testing portion, or if there's anything else that you need in order to get ready for the exam, you can let me know.
How to get the 1% in probability? Is that on there?
How to get the 1% for the cutoff scores?
It's chapter 4.
Okay, chapter 4.
Is that what it is?
Yep. Well, there's two things you might be referring to,
Okay.
and both of them are actually good questions. So one of them has to do with the alpha level and finding your cutoff scores.
What score is in the top 1%?
Okay.
Scores in the normal curve table?
Right. You want to see that one more time?
Yeah, because I thought I got it and I kept getting the answer wrong. So
Okay. Okay, so for questions like that, one thing you want to make sure that you do is have these steps somewhere. So it would be a great idea to just have them ready to go in your notes for exam number 3. So when you're asking for, what score will get you into that top 1%, what you want to do is first and foremost draw your normal curve. Make sure that you have that going. So I'm going to borrow a normal curve here. So you can draw your normal curve, and I'll use the same numbers that we have here. So we have a mean of 500, and we have a standard deviation of 100. And we want to know what score do you need to be in the top 1%. So it doesn't even have to be accurate. Like this is nowhere near 1%. But that is the 1%, the top 1%.
Yeah.
So basically we're asking what score do you need to be in this top 1%. Now because, once again, we're in that situation where this is nowhere in your appendix. So what we need to do is we need to convert this into a z-score distribution so that we can use and find that z-score that'll put us in the top 1%. So we convert it into a z-score distribution, and we still want to know what score will now get us into that top 1%, right? What z-score will get us into that top 1%. But fortunately, now we can actually look this up in a table. So let me just get that table here. And you'll notice I skipped the rough estimate one. You can do the rough estimate if if you need that final double check. But now we have that we want 1% in the tail. So the reason you draw this out is because you don't want to lose your train of thought and pick the wrong column. So we go to the column that's percent in the tail because it looks like the one that we want. And in the percent in the tail, we find 1% in the tail. And be sure that you remember that these are in terms of percentages, not decimals, right? So this is 49%. This is 0.99%. This is not 99%, right? Some students sometimes make that mistake, especially when they're dealing with alpha levels, and I'll get to that in just a moment. But we find the one that's closest to our score, which is that 1% right there. And then we get the z-score that's associated with that, which is at 2.33. So now we know what z-score we need to be to get into the top 1%. So the last thing is we got to take that z-score that we just found and we have to retake it back to our original distribution so that we can get the raw score. So we do that by going with the raw score that we're looking for is equal to the mean of the distribution And this is that formula where we were, when we were working with z-scores a bunch. It equals the mean of your distribution plus your z-score times your standard deviation of your distribution. So that's going to be 500 plus 233, and that's going to be 733. And that's how you get that raw score for the top whatever percentage.
Okay.
All right, so do you mind if I?
Yeah.
Okay, so when you're doing a one-tailed test, it is imperative that you determine whether it's looking for an increase or a decrease, and then make your decision based on where your sample ends up. So if they are looking for a decrease, right? So for example, the practice problem says, were scores on depression lower, for the teenagers? That indicates that you're looking on this side of your comparison distribution. So you put your alpha all into that side. So was it 5%? Okay, so you put all 5% into the lower side because you were only interested in if depression scores are lower. So that's going to give you a z-score, and the z-score was minus 2 point what?
2.81.
No, the cutoff score.
Oh, 1.64.
1.64. So that's minus 1.64, importantly, because it's on the minus side. If it was positive 1.64, it would be over here. And then the logic of what you're doing does not change. For every single test, if your mean for your sample makes it into the tails, you reject your null hypothesis and you say the treatment has an effect. If your mean stays in the body, you accept the null hypothesis and you say that your treatment does nothing. So in this case, our mean ended up having a score of minus 2.87, you said?
81.
2.81. So this one had a score of minus 2.81. That put it into the mean, that put it into the tail. That's when we reject the null hypothesis. Now, just because this is minus, you can't assume that this is going to be minus as well. You have to make this decision first, and then you find this score here. Because occasionally, people will say, well, I'm interested in whether this treatment causes a decrease, right? Does this treatment cause a decrease in depression levels? And maybe it causes an increase, right? Maybe they came up with like depression poison and it actually makes depression worse. It's quite possible that in a one-tailed test, your mean will end up somewhere over here. And it might have a score, a z-score of, let's keep it positive 2.81. If it does, you can't look at this positive 2.81 and say, well, 2.81, if this was on the positive side, 1.64, this would be in the tail, so I'm going to reject the null hypothesis. That's not the way that it works. This score here has put your mean in the body. Importantly, it has not gone into the tail. So it doesn't matter how extreme your mean is on this side. As long as it's in the body of your distribution, you accept the null hypothesis. And you would say that this treatment does not lower depression, right? In fact, it looks like it increases depression, but we know for sure it does not lower depression because it didn't make it into this side. So when you're doing your one-tailed tests, be sure to look for that language that indicates what side of the distribution you're looking for. So they are asking, does this study lower depression? Do people have, less money than previous generations? Do incidences of accidents decrease after this commercial intervention, right? All of those things, less than, decrease, lower, all indicate this side. You should have a negative cutoff score for your negative tail. If, on the other hand, they're asking whether the treatment causes an increase, right? Does this treatment increase resilience? Does this treatment increase, is our scores bigger than they were before? Are people making more money than they were before? Is the problem greater than it was before? If that's the case, then you are on this side, and you put all 5%, for a one-tailed test, you put all 5% into the positive side, and you end up with a positive cutoff score rather than a negative cutoff score. But the decision is always going to be the same. You find out where your sample is on this unit normal comparison distribution, and if the sample is in the tail, you reject the null hypothesis, you accept the research hypothesis. If the mean, the sample, stays in the body, then you accept the null hypothesis and you reject the research hypothesis. So that's the general principle for the one-tailed test. So again, yeah, make sure that you put that in. Now, just very quickly, for a two-tailed test, and you'll remember this from your homework, you have both sides. You got the negative and the positive, right? So if, I erased my two-tailed, but if this was a two-tailed test, you would have two tails, and you would have a minus z-score and a positive z-score. On the exam, I'm going to assume for your two-tail that you mean plus and minus. So you don't got to put plus or minus in there. You don't have to put both of them in there. You don't have to do anything except just tell me the number. And I'm going to assume you mean for a two-tailed plus and minus. For a one-tailed, to get full points, you have to keep it a positive. You don't got to put in plus, but you got to put in a positive number. If it's a positive tail looking for an increase in scores, you got to put in a negative cutoff score. If it's a negative tail looking for a decrease in the scores in order to get full points.
So for this question, you would have to put minus?
Minus.
Okay.
So the 1.64 should be a minus 1.64. Yep.
I have a question about number one.
All right, so one other thing that I just kind of had a flashback to. When you are dealing with alpha levels, in psychology, there are basically two alpha levels that are used the most often. The most common one is an alpha level of 0.05. All right, and then the second most common one is an alpha level of 0.01. And these are pretty simple to do, pretty straightforward when you're doing a one-tailed, right? So if it's a one-tailed test with an alpha 0.05, most students completely fine to go, okay, that's 5%. If it's a one-tailed test with an alpha 0.01, most students no problem going, that's 1%. When they get to two-tailed tests, where you got to take your alpha and you got to split it into two tails, usually for the alpha level of 0.05, students are pretty good at getting to the fact that you need 2.5 in one and 2.5 in the other, right? So you need 2.5% in each tail. They'll usually get that pretty well. Sometimes though, when I see this one done, they do it incorrectly, and when they divide it by 2, for some reason they end up with 0.05 rather than 0.005, and they end up putting 5% and looking up the wrong cutoff score. So what I would recommend for the alpha levels is make sure when you're given them in decimal form, and that's the form that they are always put in APA format in psychology journals, you will see alpha levels of 0.01, 0.05. You will never see an alpha level of 5%. Nobody writes it out as a percentage. What I would recommend is somewhere write it out as a percentage first, and then cut that in half, because half of 1% will be much more straightforward to get to that 0.5%. And then if you've already converted it to percentages, you know to look up 0.5 on the unit normal distribution table and not to mess around with this number anymore. So it's just a little something I've seen before when students have difficulty cutting the 0.01 into the two sections for the two-tailed test. Because again, you get into that 0.005 and then you got to convert that to a decimal. So there's a lot of places where you can go wrong if you cut the decimal into first. So I would say convert the decimal to a percentage first, cut that in two, and it'll cut down on any unnecessary little errors. Well, finding the negative, I mean, I just real quick kind of shed some light on those ones. So when you're dealing with the unit normal distribution table, which you basically will for most of the exam. So there's very few questions on the exam where you will not be opening up Appendix A1 and using that to help you answer your question. But one of the things about Appendix A1 is that it's only positives.
Okay.
So when you're dealing with whatever question you have, the kind of thing to do is always draw it out, right? So they might say to you something like, you know, what percentage is above, you know, a negative score, right?
Okay.
So if they say something like, the example we had before was, you know, what percentage is above SAT score of 333?
Okay.
Well, 333 is below the mean, so it's going to give you a negative z-score, right? So we're ending up with a negative z-score, a z-score that's somewhere over here, right? So that's our z-score. And if they want to ask you, well, what's the percentage that's above that z-score? Well, then you're looking at this area here, right? Plus this area here, which is the 50%. Okay, so half of this that's above, that's the 50% because it's symmetrical, that's half. So this is the only thing that we need to look up.
Okay.
So we would have our z-score, let's say that our z-score is minus 1.5 because we've calculated it out. And that z-score is nowhere in the table. But what we basically need to realize is that this is the same area, that's the same percentage as the mirror positive version of this. Where we have a z-score of positive 1.5. And then we have this area here. And then we have that 50%. Right? And this is in the table. So whenever you're dealing with, whenever you have a negative score, just you know, be aware that draw out your distribution as is, color in the area that you're interested in, and then you can just mirror flip it. And if you need to draw it out to mirror flip it, please do so, because when mistakes are made, or when people try to keep so much information in their minds all at the same time, and that is just a recipe for disaster. Because it doesn't matter how intelligent you are, we have limits on how much we can put into our working memory. So this might be a good time just to kind of give you a little, does everybody know about in cognitive psychology? You probably encountered this in general psychology. It's literally one of the most cited psychology papers of all time, but it's the magic number 7 plus or minus 2. Does that ring a bell?
Ideas you can hold in
The number of ideas that you can hold. All right, so everybody has typically in their working memory 7 slots that they can place information into, plus or minus 2. Some people get 9, some people get 5, but everybody's got basically that amount of slots. And I mean everybody. I mean, like, Bill Gates has that many slots, Neil deGrasse Tyson has that many slots, Meryl von Savant has that many slots. These super intelligent people are not super intelligent because they get more working memory. But what happens is that if you have somebody who's been a statistician for a while, right? We got 1, 2, 3, 4, 5, 6, 7, right? If we could look into Dr. Fujita's brain and you asked him to do a hypothesis test, his inside of his brain would look much different than the inside of your brain here, right? So you still have 7, 1, 2, 3, 4, 5, 6, 7. But because this is new to you, because you're practicing these skills, because you haven't developed that practice yet, step 1 here is your null hypothesis and your research hypothesis. That's occupying 2 slots in your working memory. Step 2, the comparison distribution. That is the comparison distribution not equal to, the population of individuals. Step 3, you got to calculate out, I'm mixing up the steps here, but step 3, your cutoff score, right, score. And then step, in another slide here, is what to do if you have a negative cutoff score. And then step 4 over here, what is the formula for a z-score? Step 7 over here, what is your sample mean? What is your comparison distribution standard deviation? It fills up and it spills over, and you can't keep everything in your mind all at once. That's why, number 1, you're in this course, right, to develop these skills. And that's why it's going to be very beneficial for you to unload as much as you can out of your mind and onto some visual aid, some memory aid, right, that you can then access. So that's why it's good to have this somewhere ready to go, because you don't need to keep all 5 steps in your mind. That's why it's good to draw out your distribution on paper, so that you don't need to keep your paper, that distribution in your mind. And when you see a experienced statistician do a hypothesis test, for example, somebody like Dr. Fujita, he still has 7 slots. It's all the slots that he has, right? He's not a cyborg sent from the future. But because he's done this so often, his hypothesis testing is 1 step. So when he looks at a hypothesis test, it's just 1 step. All 5. All of these little pieces, for him, because he's so practiced, have become 1 move. So if he has to deal with negatives, yeah, he's got all this leftover room here to do double negatives and triple negatives and all the mental gymnastics that he might want, but we're not quite there yet. So the more you can offload, the more slots you open up to help you think about what you're doing. All right, and the less you offload, the less you have down in your notes, the more you gotta rely on your own cognitive processing, and you will get overwhelmed, and that's why a lot of this seems difficult at this time. So that's, my little PSA. That's why I keep saying draw out the distribution, because there's 4 things going on here, right? There's where's your z-score? What part do you want? This part is 50%, and we got to flip it. That's 4 things. You can either dedicate half of your working memory capacity to dealing with those 4 things, or you can dedicate 1 slot to it by drawing it out and then just saying to yourself, you know what, I have that somewhere. I can look at it when I'm ready. So do draw it out. That's why I give you the rough sheets of paper, so that if you're not a notebook person, you have places to do it. But I would highly recommend that, because why make it harder than it has to be? Offload those all that cognitive work. Use those memory aids, and it'll be and you'll just leave yourself so much more processing power to make sense of the question. So just so that we have the complete package when we're looking at the types of hypotheses tests, we spent a lot of time today talking about the one-tailed test. Looking for language, like, is it an increase? Did scores get bigger? Was there greater, scores after the treatment? That indicates a positive cutoff score. That's a one-tailed test that's on this side of the distribution. Looking for a decrease. Did scores go down? Was there less after treatment? That indicates scores on the other side. If you don't have any language that indicates a direction, that indicates a two-tailed test. So if the language are things like, Is there a difference? Did the treatment have an effect? Right? Did scores change? Right? Those are all indications of a two-tailed test. Because did the treatment make a difference? Could be yes, it increased scores, or yes, it decreased scores. Was the treatment, did it have an effect? Yes, it increased scores, or yes, it decreased scores. So that's your indication kind of in the real world that you're looking for a two-tailed test. In the exam though, for sure, read that final line, because in that final line, I will tell you, number one, how many tails for your test. So is it a one tail, is it a two tail? And that will not contradict the story that you were told either. So if the story is saying, oh, they were looking for an increase, it will say, do a one tail test. If the story says, oh, they were testing for an effect, it will say, do a two tail test. But then make sure very carefully that you check your alpha. Because your alpha level, we're going to use the most common ones in psychology, which is 0.05 and 0.01. That's your alpha level. And that you need to know because that determines your cutoff scores. So if you're doing a one-tail test and it's an alpha of 0.05, you put all 5% in one tail. If it's an alpha of 0.01, you only put 1% in that one tail. That changes where your cutoff score is. So be sure that you also make a note of that, what the alpha level is. Otherwise, you've basically taken a chance on getting your cutoff score incorrect. All right, so got about 15 minutes left, and what we're going to do right now is we are going to go through one more of these percentages to the top. Find what's in here, find what's in there, kind of percentages. So let me bring up that practice sheet. All right, so I think that's the one. Okay, and the question that was being asked was this one here. So the salaries for nurses in the U.S. are normally distributed with a mean of 50,000 and a standard deviation of 13,000. Apparently, that is correct, except for it being normally distributed. So if you want to use that at a dinner party or something, feel free, but do not. For the normally distributed, that's just for educational purposes. All right, so anyways, that's the situation. Mean salaries for nurses in the U.S. normally distributed with a mean of 50,000 and a standard deviation of 13,000. So we have our distribution here. The mean is going to be 50,000, and the standard deviation is 13,000. And question A goes, what salary would a nurse need, would a nurse's need to be in the top 15% of all salaries? So let's say that you just wanted to make sure that you are in the upper 15% of nurses in terms of earning, right? Let's say that you're being interviewed and they go, well, what salary would you like for your job? And you're like, well, I want to make sure that I'm in the top 15%. How much would you need to ask for? So once again, we're in this situation here where we've identified, we've drawn it out. We know that we want this top area right here. That top area is at 15%. But what's the salary that we need? So we need to convert all of this into your unit normal distribution table that we can look up. So once again, we have our table, mean of 0, standard deviation of 1. And we know that we want to be in the top 15%. So that is that area right there. And the question now is, well, what z-score do we need in order to be in the top 15%? So for this, we would go to our unit normal distribution table. and we would look up 15% in the tail. So does anybody have quick access? I don't have my textbook open. Anybody have quick access to the table and let me know what is the z-score associated with 15% in the tail? Yep.
Does it have to be like exactly 15%?
It's got to be the closest to 15%. So do you have it?
Well, I mean, I have like 15.15,
Okay, and what's the next one?
14.92.
Okay, so in that case, you're looking in the right area. So the closest is 14.92, so that's only 0.08 away.
Okay.
So that would be a z-score of 1.04. All right, so we found the z-score. The z-score is 1.04. And this is one of those cases where we don't have the exact z-score, so we got to go with what's closest. So 14.92% was the closest we could get to 15%. That's our z-score right there. And now the last thing we need to do is we need to take that z-score and we got to convert it back into an actual amount of money. And for that we use the formula where your raw score equals your mean plus your z-score multiplied by your standard deviation. So that would be 50,000, because that's the mean earnings, plus your z-score, which is 1.04, times your standard deviation, which is 13,000. So you'd end up with, what do we get here? 48, 52, 63,520. Anybody want to check my math? What's that, my calculator? It's a race. Yeah, I did get it right. Hey, mental math. All right, so anyways, that's the score that you need. That's the raw score. That's the salary you would need to put yourself into the top 15%. So the next one is a good one to go through as well. It's doing the opposite, where you're starting with a raw score and you're ending up with a percent. But this one is going to be nice because it has that negative. We're going to end up with that negative in it. So for example, this would be the case for a nurse that was just starting out, entry level, sort of hierarchy. So what percentile rank is a nurse in with a starting salary of $30,000? So there's your $50,000 right there. And $30,000, it doesn't really matter where we draw it. It's just got to be on the right side. So don't worry at all about being, well, is this really 30? Isn't this more like 30 or is 30 over here? Doesn't matter. It's on the negative side. That's all that we need. And it wants to know what percentile rank are you with a starting salary of 30,000. Percentile rank, you can Google this during the exam. Feel free if you forget what percentiles or percentile ranks are. Your percentile rank are the number of people that scored at your score or below. So if you're in the 97th percentile, that means 97 of people score as high as you or below. That puts you in pretty elite standing. $30,000, how many people are at that salary or below? It's this tail right there. Those are the people that make that much or below. So what we want to find out is, well, what is that percent? So once more, we have to convert this into our unit normal distribution. But this time, we're gonna, well, we'll do it step by step. So we're gonna convert it into our unit normal distribution. So once again, mean of 0, standard deviation of 1. And now we got to find out where does that 30,000 put us, right? What is the z-score? We got to convert That's that salary of 30,000 that we know. We got to convert that into a z-score. So we go to our z-score formula, where your z-score equals your raw score minus your mean divided by your standard deviation. So that equals our 30,000 minus our 50,000, all of that divided by our 13,000, and that's going to give us 1, 2, 3. That gives us 1.54. So we get our z-score of 1.54, and now we can look it up in the table. What is the percentage associated with 1.54? Sorry, minus 1.54. I jumped a step. So we have minus 1.54. So now we're almost ready to look up what is the percentage associated with minus 1.54. Because we don't actually have minus 1.54, we just realized that this is the mirror image of positive 1.54. That is in the table, so if somebody can look up the percentage for that. 6.18. So 6.18% is in the tail for a z-score of 1.54. So in this case, what percentile rank is a nurse with a starting salary of 30,000? If you have a starting salary of 30,000, you are in the 6.18 percentile, meaning that just about 94% of nurses make more than you, in which case you probably want to go and ask for a raise once your probationary time is finished. And that's basically it. I mean, one of the nice things about where we're kind of going right now with the statistics course is that most questions that we're going to be asking are going to be, the same version of the question. So those two questions there, that's basically all you can do with these types of questions. You can start with a raw score and end up trying to figure out a percentage, or you can start with a percentage and end up figuring out a raw score. And it's always going to be the same steps, right? Maybe some minor variations because you end up with a negative and you got to flip it. But it's always going to be the same steps. Hypothesis testing, always going to be the same steps, right? Maybe some minor variations with a one-tailed or a two-tailed test. But all one-tailed tests are pretty much exactly the same. Every single one-tailed test that asks, did the scores increase, are all the same, fundamentally. Sure, there's different numbers, but they all have the same exact structure. Every one-tailed test that asks, is there a decrease, all have exactly the same steps and structure. Every two-tailed test has the exact same steps and structure. So it's getting to the point where if you can lock down those 5, procedures, you'll be good to go for exam number 2. So try to start seeing the regular patterns, the commonalities. As you practice more, you'll realize, oh, I'm doing the exact same thing over and over and over again, and pretty soon you'll be able to say it's the exact same thing over and over again. I don't need 7 slots, I can do this in 4, and that's when things start to feel way more straightforward in terms of being able to accomplish those goals. All right, we got about 4 minutes, so if there's any final questions, this would be the time. All right, so that is it for this review session. I think that was quite a productive review session, so hopefully it'll help everybody in the upcoming exam, and hopefully your fall break will be fun, and I will see you literally next week.